In this section, we are going to discuss about the inter-subnet communication or communication into different subnets. So we will see mainly the practical part, and for the packet flow, we will see that in some another section. So in today's scenario, we will take spine 1, leaf 4, and leaf 5. So we have endpoints which are connected to leaf 4. So we'll take an example of host 3, which is connected to leaf 4. Host 3 is having an IP address of 10.1.1.4 and MAC address ending with 3333. So we'll see the communication between host 3 and host 6. Host 6 is connected to leaf 5, which is in a different subnet and different VLAN. So host 3, which is connected to leaf 4, it is into VLAN 10. Host 5, host 6, which is connected to leaf 5, it is into VLAN 20. So now, because we are talking about different subnet communication, so on the hosts, we have default gateway configured, okay? So on host 3, we have default gateway configured, which is 10.1.1.254. So as you know that we need to configure that default gateway somewhere. So we'll configuring the default gateway on our leaf switches under the SVI. For example, host 3 belongs to VLAN 10. So under SVI 10 only 4 will be configuring 10.1.1.254, which will be the default gateway for host 3. Likewise on host for host 6, which is in VLAN 20. So only 5 will be configuring SVI for VLAN 20. So we are going to use a concept of Anycast gateway. Let's understand what is the meaning of Anycast gateway. So let me go to Paint. So consider this situation. So we have, let's say, we have host 1 here, which is having an IP address of 10.1.1.3. Okay, and MAC address of 1.1111. Now let's say that we have SVI 10, okay, on leaf 3, which is having this IP address configured, and the MAC address for this particular SVI, it is using, let's say, AAAA, okay. And on leaf 5 also, you can see that we have host 5, which is also in VLAN 10, and it is having the IP address of 10.1.1.5 and MAC 5555. Let's say that on leaf 5 also we have SVI configured for VLAN 10, and let's say it is having IP of 10.1.1.253, and it has this particular SVI, it is having the MAC address, let's say BBBB. Okay, so everything is working perfectly and there is no problem in our network. This particular Anycast gateway that we are going to see today, it is mainly for vMotion kind of scenarios. Let's say this particular host 1, it moved from leaf 3 to leaf 5. Okay, so now host 1 moved from leaf 3 to leaf 5, but it retains its IP address, its MAC address, which is 1111, and also the gateway IP address, right? Which is 10.1.1.254. So on host 1, in the ARP table of host 1, there will be entry for the gateway, right? 254 and its MAC address AAAA. So this particular host moved from leaf 3 to leaf 5 as it is. With the IP address, it is having its own MAC address, the gateway IP, and the gateway MAC address. Okay. So now you can see that because now host 1 moved from leaf 3 to leaf 5. Now we have a problem because now host one cannot communicate because it is having the gateway IP address of 10.1.1.254, right? If it needs to communicate into different subnet, it is going to use this particular IP address 10.1.1.254. It will send the traffic to gateway IP 10.1.1.254, and it is going to use this particular MAC address AAAAA, which does not belong to leaf 5. That is why now leaf 5 is going to drop this particular traffic, and now we have a black hole kind of situation for host 1. Host 1 is now isolated because of vMotion. That is why it is important that on all of our devices we use the same gateway IP for the SVIs, so that in case a host moves from one location to another, there will not be any isolation for that particular host. So now what we will do, uh, we will use same gateway and MAC for SVI 10. So we will use the same SVI and same SVI MAC address for VLAN 10. Now it does not matter that host 1 moves from leaf 1 to leaf 5. In fact, on leaf 4 also we will use the same SVI and MAC address for the gateway IP. So now in this situation, it does not matter for host 1 if it moves to leaf 4 or leaf 5, because now it will not be isolated from the network, right? It can use the same gateway IP or the MAC address AAAA, and it can communicate perfectly as it is. So this IP address that we are configuring on leaf 3, 4, and 5 on each leaf device, the same SVI IP that we are configuring, we call it the Anycast gateway IP. And the same MAC address that we are configuring AAAA for this SVI, we call it the Anycast gateway MAC. Okay. In fact, for all the SVI that we will configure on these devices, see, for SVIs we'll be using the different IP addresses, right? For example, we have SVI 10, so we'll use the IP, let's say 10.1.1.254. On all leaf switches, we'll use the this particular IP for SVI 10. Let's say we have SVI 20 also, so we'll use a different IP, right, for SVI 20, like 20.1.1.254. That will be same on all leaf switches, but the IP address will be different for different SVIs. But we are going to use the same MAC address, the Anycast MAC address for all the SVIs. Okay, so this is the concept of Anycast gateway IP and Anycast MAC address. So you can see that our host or our servers are directly connected to the leaf switches. So we are providing with them the gateway IP address uh, as close as possible. Okay, so in our legacy devices, as we know that we have a flat layer 2 network, so our server will be connected to some access device or access switch. Access switch will be connected to some distribution, and distribution then will be connected to some core device. And on the core device, we configure the these SVIs or the gateway IP addresses, right? But here in this situation for the VXLAN, as our servers or our end host, they are directly connected to our leaf switches. So we are providing them the gateway address directly on our leaf switches. So I hope now the Anycast IP address or Anycast gateway IP and Anycast gateway MAC addresses concepts are clear to you. So I'll show you how we are going to configure them. So I'll show you for inter-subnet communication what is the configuration. So I'll open the notepad. So you can see that I think these particular features we have already discussed: NB, overlay, VPN, feature OSPF, BGP, PIM. You can see one more feature that you can enable is feature fabric forwarding. Then all the rest of the features we have already been discussed, right? Now this is the command that we need to configure uh, on the global configuration mode, because we are going to use the same MAC address for all the SVIs, right? So the command is fabric forwarding anycast gateway MAC and then the MAC address that you are going to use. I'll show you this in my configuration also. If I go to, let's say, leaf 4, if I do a show run pipe include Anycast, you can see that I configured one this Anycast gateway MAC address, and you have to configure it into global configuration mode. Okay. Then you need to configure a new VLAN. Okay, let's say any VLAN number that you can think of. So let's say in my example, I took one VLAN 1234. So this VLAN is particularly we are configuring for the L3 VNI, because we are talking about the symmetric IRB, right? So it will use the concept of L3 VNI. So we need to configure a VLAN, let's say 1234. I name it L3 VNI VLAN. You need to configure the VNID or the VNI ID against this particular VLAN. I configure it 1234 1234. Now under the VRF, so we need to configure one VRF. Okay, so for example, I configure VRF customer A or cust A. Okay, so for VRF customer A, now you need to map this VNI. Okay, that we configured right now. So VNI 1234 as this is a VRF, you need to configure the RD value. So I configure the RD as auto. Now you also need to configure the route target. Okay, a route target both I set as an auto. Then what else? So you need to configure two SVIs. Okay, so VLAN for VLAN 10 and VLAN 20, I configure these two SVIs, and they'll be a part of the same VRF, customer A VRF. We need to configure the IP address, and also under the SVI we need to configure fabric forwarding mode anycast gateway. Okay, so we need to tell this particular SVI that this particular IP address 20.1.1.254, it will be working as the Anycast gateway. So same configuration for VLAN 10, interface VLAN 10, fabric forwarding mode Anycast gateway. Then the VLAN that we configured for L3 VNI, we don't need to configure any IP address. We just need to define the VRF, that it is a part of customer A VRF, and we just need to configure this command IP forward. Okay. Then there is nothing much under the interface NVE1. Everything is same as per our previous example that we did for multicast. So we need to define host reachability protocol BGP, that this particular command we also discussed when we took the example of ingress replication using BGP. So we need to define that the host reachability protocol is BGP. And this is the only command that we need to configure under the interface NVE1 apart from this host reachability protocol BGP. That is member VNI, the VNI number, and we need to configure this keyword associate VRF. That's it. This is the only configuration that we need for the inter-subnet communication. Okay. I can go quickly again. So we already discussed about the features. You can see here. Then we need to define the Anycast gateway MAC under the global configuration mode. We need to define a separate VLAN to define the L3 VNI. Then under the VRF, we need to configure one VRF, and the L3 VNI, we need to map with this particular VRF. We need to define the RD and RT value for this particular VRF. And under the SVIs, we need to configure the gateway IP, and we need to define this particular command for the Anycast gateway. Under the L3 VNI VLAN, we don't need to configure any IP address. We just need to define the VRF and this particular command IP forward. Under the NV interface, just two commands, extra commands: host reachability protocol BGP, member VNI number, and then the associate VRF command. Okay, I'll show you the configuration also. If I do a show run interface VLAN 10, you can see VRF, IP address, and this particular command. Show run interface VLAN 20. You can see that we have same IP address and this particular Anycast gateway command. What else? Show run interface NVE1. You can see we need to define this particular configuration and the host reachability protocol BGP. Show run interface VLAN 1234 for the L3 VNI SVI. We don't need to configure any IP address. We just need to define the VRF and this particular command IP forward. That's it. This is the only configuration that is needed on leaf 4 and leaf 5. And you can see now if I go to the diagram, only 4 interface Ethernet 1/3. If you see show run interface Ethernet 1/3, it is into VLAN 10, and only 5 interface 1/4, leave 5 interface 1/4, it is into VLAN 20. So let's try to ping from host 3 to host 6. Host 3 is having an IP address of 10.1.4. Host 6 is having an IP address of 20.1.1.5. First of all, let me check if we have the SVI is up. So SVI 10 is up, 20 is up. If I go to switch 5 or leave 5, show interface VLAN 10. VLAN 10 is down here. Let me unshut it. Show interface VLAN 20. 20 is up. So now let's go to host 3. Show IP interface brief. So host 3 is having an IP address of 10.1.4. So we are going to ping from host 3 to host 6, which is having IP address of 20.1.1.5. If I do a ping, you can see that we can ping from host 3 to host 5, which is into different subnet. So if I go to a leaf switch, for example, if I do a show MAC address table, now you can see that we are learning only 5 the MAC address and we are learning it from leaf 4, which is correct, right? So I have some problem on leaf 4, which is not behaving properly. So I'm not able to see the MAC address, but it is perfectly working. So we can have a look at the output at leaf 5 only. So it will be good. So on leaf 5, you can see that we are learning the MAC address of host 3, which is behind leaf 4. Also, if you see the show BGP L2 VPN EVPN summary, so we are having the BGP configuration with spine. So I did not show you the BGP configuration, but you can have a look. It is this exactly same like we did into the ingress replication for BGP. We just have the BGP configuration into the address family L2 VPN EVPN with the spine, which is acting as a route reflector, right? So you can see that we have the BGP neighborship. You can run this command, show BGP L2 VPN EVPN summary. If you want to see the routes that we are learning from the route reflector from spine, you can run this command, show BGP L2 VPN EVPN enter. Now you can see that we are learning about host 3, the MAC address, as well as the IP address. And I told you that for a route type 2, which consists the IP address plus the MAC address, the slash value will be 272 because uh, it is containing the extra information of the IP address, which is of 32-bit, plus the VNI information or the layer 3 VNI information. You can also check it like this: show BGP, L2 VPN, eVPN, and let's say I want to check about host 3. Okay, I'll say enter. Now you can see that we are learning about this particular endpoint from router 4, right? You can see that the originator is router 4, and who is providing us with this information? Route reflector or spine. You can see that we have the IP address of spine 1.1.1.1 or the router ID of spine. Then you can see that we have the received label. So the received labels are, we have the L2 VNI information, right? You can see that because end host or host 3 is a part of VLAN 10. So, and we have the VNI for VLAN 10, which is 10, 10, 10, 10, right? Also, we are receiving the L3 VNI, right? That is why we have a slash 272. Then into the extended community value, we are receiving the route targets, right? You can see that because we are having the route target set as an auto, so we have the route target value, which is the AS number, BGPS number, colon, the VNI number, right? This is the route target value for L2 VNI, right? Then we have the route target value for L3 VNI, which is BGPS number plus the L3 VNI, right? Then we have the in-cap number 8, which is used for VXLAN. And then we are receiving the router MAC. Router MAC is very important. We'll discuss about this when we will discuss about the packet flow for inter-subnet communication. So we are also receiving the router MAC into the extended community. This is the router MAC for leaf 4 because this particular endpoint is originated from, or who sent this particular information. It is leaf 4, right? This endpoint 10.1.1.4, it lies behind leaf 4. So we received the router MAC of leaf 4. You can also verify it if I go to leaf 4, and if you do a show NVE interface, you can see that local router MAC for leaf 4 is ending with 0007. That was same, right? You can see 0007. So we are also receiving the router MAC of leaf 4. So likewise, you can also check the MAC address also with this particular command, and you can have the same information. Okay. What else you can see? Also, I can show you that we'll discuss into the packet flow so that there are a lot of devices that do GARP, okay, to populate the ARP table of other devices into the network. We can take a simple example of, for example, we have this particular virtual PC that is connected to leaf 4. If I configure any IP address, so it will check the duplicate IP address and it will generate a GARP message which will be received by leaf 4, and it is going to generate a BGP VPN update, and the other devices will also get to know about the detail of this particular device. Okay, let me see this device. Okay, so I can configure any IP addresses. For example, earlier I configured this. I think this is connected to, I'm not sure. I think it is connected to. Anyways, let's try. We'll see where exactly it is connected. So let's say I configured it. I think it is connected to, let's say 36. I think it is connected to this leaf 5, I guess, but it is not on. So let's try to start it. If I go to leaf 5, you can see that whenever we uh, provided the IP address for this particular virtual PC, you can see that it is checking for the duplicate IP address. So it is doing a GARP, okay, to check the duplicate IP address. Let's see if we receive this particular information. If I do a show MAC address table, or if I do a show BGP L2 VPN EVPN, so you can see that we have 20.1.1.36, right? So as soon as you can see that we did not do any ping, right, for from this particular virtual PC, which is having this particular IP address 20.1.1.36, because as soon as we connected this into the network, it did the GARP to check the duplicacy, and our BGP VPN tables are populated. You can see that only 5 and only 4 also. You'll see this now. Show BGP L2 VPN EVPN, and and you can see here the information about 20.1.1.36, right? If I do something like that, so the router MAC is 0007. I think it is the same device which is connected to leaf 4. So this virtual PC seems to be connected to leaf 4, right? If I go to leaf 5 and if I run the same command, so now you can see that this particular, the router MAC is 0007, which is for router 4, and even on router 4 or leaf 4, you can see that it is self-generated. That is why you can see here 0000 and 444, which is the router ID of leaf 4. So this is how the inter-subnet communication takes place. Okay, you can also see show IP route VRF. So you can check, you can see that into the VRF table, now we have the endpoint information. For example, you can see that earlier we pinged from host 3, which is connected to leaf 4, to host 6, which is connected to leaf 5, and host 6 was having an IP address of 20.1.1.5. You can see that leaf 4 is learning 20.1.1.5 via the BGP VPN update, right? You can see here the EVPN update, and it is learning it from 555. So in this particular lab scenario, these devices, they are not supporting type 5, route type 5. Otherwise, I'll show you and I'll discuss it into the packet flow that as soon as you configure the SVIs on our devices, our leaf switches, they are also going to generate a route type 5 for the IP subnets. Okay, for example, in our scenario, we configure this show run interface VLAN 10. So leaf 4 and leaf 5, both they are going to generate a route type 5 for this particular subnet 10.0.0.0/8. Okay, I'll discuss into the packet flow what is the use of the route type 5. So I hope this inter-subnet communication is clear now. Let me see what else I can show you. Show BGP L2 VPN EVPN summary. You can check the BGP summary. This is spine 1. You can also check something like that, what we are advertising to the neighbor. Advertised routes. Now you can see that we are advertising our local routes, which is 333, and this is for the virtual PC, right, that we configured. And this one also we configured earlier. So, but in our example, you can see that if you go to leaf 5, show BGP L2 VPN EVPN summary, show BGP L2 VPN EVPN neighbor and advertised routes. Now you can see that we are advertising these particular routes to this spine. Okay. So this MAC address, this is 666. This is the host 6 MAC address, right? And this is the IP address of host 5. And you can see a slash value. And both these IP and MAC we are advertising into route type 2. You can see into the bracket, right? What else? What else we can check? Show BGP, show IP, BGP, unicast. There was one more command, show BGP, IPv4, unicast, VRF, customer A. You can see the routes 10.1.1.4, right? These are the routes that we are receiving, right, into the customer via the BGP VPN. You can see that the route 10.1.4, which is host 3, and this is the virtual PC, right? VRF I have already shown you. So for the, you can also check show BGP L2 VPN EVPN, the um, end host that we are learning from router 5. You can also see the router MAC that we can also verify 1B08, which is the router MAC of leaf 5. If I do a show NVE interface, you can see the local router MAC 1B08 and the host learning mode now, because we are running BGP, so it is control plane. Show run. Also, you can see show NVE peers. With this command, you can see that we have the NVE peer 4444. So this was all, I think. Show run section. I think BGP I have already shown you. We did not have much into this. And onto the spine also, I verified with you the configuration. There is nothing much here. If I do a show running configuration, we have some features that we already discussed. And we have multicast for the bump traffic. I mean, if we are communicating into the same subnet, so we have already configured the multicast for that. And into BGP, we have simple BGP VPN neighborship with router 4 or leaf 4 and leaf 5. And spine is acting as a route reflector. You can see show BGP L2 VPN EVPN. It is receiving the endpoint information from leaf 4 and leaf 5. One more thing I would like to show you, show an interface NVE1. Sorry, show running configuration. Sorry, it is the spine switch, so we don't have the NV interface here. So you show running configuration interface NVE1. So there is one more command, this suppress R. So I'll discuss it with the packet flow because this is a lab environment and the output, or if you do a packet capture, it is not working properly. But I can explain you how exactly this suppress of feature works. So we need to enable it under the member VNI. So we'll go to the interface. So something like that. Okay, you'll go to the interface NVE1. You'll go under the member VNI. Let's say this is for VLAN 10, and you'll say suppress R. Same thing you'll do for, let's say, member VNI 202020, and you will do a suppress R. This is the only command for suppress R feature, but I'll explain you that how exactly suppress R works. Okay. If I do a show running configuration, you can go through quickly. We discussed about the features. We discussed about the Anycast MAC address. PIM, we already discussed into the multicast. So the extra configuration we discussed, we need to create one different VLAN, and we'll set a L3 VNI. We need to configure a VRF. We will call the VNI into the VRF. RDRT we need to configure. We have the interface VLAN 10, interface VLAN 20. They are working as a Anycast gateways. For the L3 VNI VLAN, no need to configure any IP address, just define this command IP forward. And under the NV interface, just the host reachability protocol BGP, and member VNI, the L3 VNI number, associate VRF. That's it. And this we already discussed into the BGP ingress replication also. This is for the L2 VRF or MAC VRF, right? So we need to define this command EVPN, then the VNI 10.10.10 L2, and we need to define the RD and RT values. So I hope the inter-subnet communication is clear to you, and see you in the next section. Thanks for watching.